All right, so I'm going to do a presentation on using Solid Edge 2D to help with chip model projects. I've done a number of things with it. I've made my templates for my models using a similar program. I've used it to design and build jigs for different projects. We could spend a week going through all the different possibilities and all the different capabilities of 2D drafting programs. So today we're just going to start out with creating a pattern for something that's the shape of a cone. I did this in the past to create buckets that went on my ship model. And when Gene was talking about his gun mounts for the Olympia, I realized it was the same thing. So this would be like an introduction to the program itself in one example. We can go through future stuff. Probably won't do it as a presentation for the regular club meeting because it would just be a repeat, but maybe we could do like workshops in the middle of the month, kind of like people have done supplemental workshops at their house for different things in the past. I know Gene did one on casting stuff, and anyway. So this is Solid Edge 2D. It's similar to a program that we have at my work, but the one at work is not free and this one is. So I'm learning how to use this so that I can recommend it to the rest of you as a zero cost option. It is by far the most capable 2D drafting program I found for free on the web. I tried a few other ones and they're just not up to snuff. This is the opening screen, so we just create a new file and you've got different standards. We'll use the standard inch setting. And it starts out with a nice background image. What you want to do though is do all of your modeling in what they call the 2D model. So this is, you'll draw everything full scale and then you'll come back to this sheet when you want to draw it or print it to a particular scale. Mm-hmm. So we'll work in this view. I have this roughly scripted out. Pardon for the any hesitations and mistakes along the way. So the first thing to point out is this prompt bar at the bottom. It gives you instructions on how to use whatever command is currently active. So this is a lot of help. If it were ever to go away, you could restore it. It's under View, and then on the left here, Show, and you can turn the prompt bar on and off here. So I usually leave that on because it's giving you tips along the way. Most of what you'll do will be at this Home tab, and these are all of your drawing commands. And you can see if we were to go through all of these, we would be here forever. I'm just going to go through some examples. This is the drawing section where you'll draw your different shapes. This is the relation section. It keeps items in sync with one another. We'll go through some examples later. Come back to this later. Dimensions, annotations. You can insert images and text. This is for viewing, zooming in and out. All right, so we'll just start in with some examples. Like I said, I'm going to create a pattern for an unfolded truncated cone. So for that, we'll need a couple of arcs. And you'll just have to play around with all these different options. The arc is here. And there's a little, every time you see an arrow next to it, it means there's some options. If you click on that arrow, you'll get options. We want to do arc by center point. So I click on that and click in the area to establish the center point. You can see at the bottom, the prompt bar I mentioned before, it says click for the start point of the arc, which I've just done. And now I can do the start and end points. Okay, and I'm going to draw another arc, center point, start, and end. I think at this point I'll point out, you see the little circles along the length of the arc. These are called handles or key points. I'm going to use the word key point. So there's a start key point, a center key point, and an end key point. And then you can see the center key point here. What is available is controlled by this IntelliSketch option up here. So if I turn off endpoints, you'll see that that doesn't show up anymore. And if I turn off midpoints, the midpoint doesn't show up anymore. Normally I keep all of these open, but sometimes they interfere. It gets kind of too cluttered. So if you're trying to do something, and it'll try and snap to the midpoint if you get too close to it, and if that's bothering you, you can just turn that off. So that's what that is. So I mentioned, we'll get to relations later. I'm going to go away from my script a little bit. What's good about this program compared to others is that when you establish a relationship between items, it keeps that relationship established. The relations are here, and you can see this button up at the top is maintain relationships. That's on. So if I draw a series of lines like so, you can see these key points I talked about are related to one another. And you see that box means that they're connected. So if I move this line, the other lines adjust with it. In all the other free 2D drafting programs I found, if you move that line, nothing adjusts. And I can show you how that would work in every other program by turning off this maintain relationships and then creating the same kind of structure I had before. I have maintain relationships turned off. Now when I drag this line, it becomes disconnected. And if I wanted to keep that, I would have to readjust everything. And that's just very time consuming. So I always keep those relationships turned on. I'm going to turn them back on now. And if you draw two lines, all right, so I draw one line. At this point, I'll point out how to, if you just keep clicking, it's going to do them one after the other. If you right click, you're restarting the command so that you can pick a new location. So I just clicked to create that endpoint. If I right click, I've stopped it. Now if I click again, I start in a new spot. And I click a second time, I create the endpoint, I right click, I've restarted it again. I have these lines that are disconnected. If I want to make them connected, I go to this relation area, and this upper left one is called connect. So now that I'm in this command, again, prompt bar says click on a key point. I'm going to click on this endpoint, and then I'm going to click on the one I want to be connected to. And now that relationship is established. And if I move this, I also point out, let me back up. I'm in the connect command now. If I want to finish, if I'm done connecting things, I click the select arrow to get out of that command and enter the select mode. So now I can select it and I can move it, and that's now, that relationship is established. Getting back to what I'm skipping what I'm doing. If you are in select mode, there's different options here for when you click and drag, you'll be creating a box on the screen, and there's different options. Everything inside the box will be selected, everything outside the box will be selected, everything overlapping. To be honest, I'm not exactly sure what directional fence is. I think it depends on the direction you drag. So if I drag up and to the left, it'll behave differently than down and to the right. I'm not sure exactly what's going on. At any rate, I'm going to drag this box and I'll select everything in it, and then I can click delete and it goes away. The zoom options are up here, so I'm going to click fit, and it just zooms to a level where everything's on the screen, and then I use the center wheel on my mouse to go in and out. Again, I'm going all over back my script completely out of order. I want to connect the center points of these two arcs for the example that we were talking about. So I'm going to go up here, and I can do it two different ways. I can use the connect command I mentioned before. When you get near the arc, it'll show where the center point is. And then I can go back to that center point, and you'll see that little target show up. That means that I'm going to select that center point. And now I can select this center point. And now the center points of those two arcs are now connected. So now if I move one arc, the other one is going to maintain the same center point. I'm going to, I'm not sure where undo is on the command, but I know if you hit Control-Z, it undoes the last operation. So I just did that. And now, actually, no, it undid my moving. Now these things are independent again. The other way to connect them is to use this relationship command, which is concentric. So if I just click that, and I can click on any two arcs, and now they have the same center point. That's an easier way to do it. All right, so our unfolded cone shape is going to be two arcs connected by two straight lines. So I'm going to connect those. With these lines, and I think you'll see that this is not yet the correct shape. We need to make sure that this line is perpendicular to that arc. So I'm going to go back to our relationships command and introduce a new one, perpendicular. I can say that line is perpendicular to that arc, and this line is perpendicular to that arc, and now I have a proper unfolded cone shape. Let me get rid of these lines again. Okay, now let me go back to my script and check off a few things. Shown lines, arcs. All right, we're going to need to dimension this. So we're going to need to dimension the inner radius. So we'll go to the dimension. And for things like simple lengths of a line or an arc, you use the smart dimension. I'm going to click that. If I click on the arc, I'm now placing the dimension of that. And I can set a value, and it will adjust the radius of that arc. And again, you'll notice everything else stretches to fit. It should have. Why did it not? Oh, that's the size of the text, not the. Oh. What happened? There we go. Oh, something's not behaving correctly. And we'll get back to that later. We'll also need the length of that line. So we can use the smart dimension, place that there. And we'll need an angle, a sweep angle from segment to segment. So I can click on this to establish the angle and pick on these two lines and give that angle. Now, I'm going to point out the angle, if you pick a key point, it's not going to behave very well. It'll do something weird like that. So when you're placing an angle, make sure you pick the line and not one of the key points. Now, if you want to do a distance between two lines instead of the length of the line, you use this distance between command, and then you can pick on key points, any key point you want, and get the distance between those. I'm going to draw some temporary lines here. I mentioned, oh, okay, Bill's joining. Bill Fox is joining. Where was I? Dimensions. Just like I said, you could right click to restart your line command. If I start doing these dimensions point to point, if I don't right click, it'll keep placing dimension using the same original one. If I want to start in a new location, I right click, and then it'll be to a new start point. Just wanted to point that out. Okay, back to the zoom commands. Already showed fit, and I mentioned that you can use your mouse wheel to zoom in and out. You can zoom in on a particular area using this command, the zoom area, and then you'll just draw a box, and it'll zoom into that area. There's also a zoom tool. I'm not very familiar with that, but it'll do basically, the instructions are down here. Left mouse, zoom in, right mouse, zoom out, left drag area, right drag dynamic. I don't use this much. I'm just going to exit this by clicking the select command again. To pan, which means move around, you can execute this command and it'll put a little hand there. It's like you're moving it around. You can do the same thing by pressing and holding down the mouse wheel. So right now I have the little mouse wheel pressed down and I can move it around. That is easier than moving up here to start the command. I can do everything without going up and down, up and down. So I prefer using the mouse wheel. Fit area to box. Okay. I can select things and then move them using this move command. So when I select this, I can click the reference point and then where I want to move it to. And it maintains the relationships between everything that you selected to move. If I move just this one item, it's going to break those relationships. So you can see it's no longer connected. So you have to be careful when you're moving things, what you're doing, or you might break some of the relationships that you wanted to keep established. Another thing you can do is keep something so it's always horizontal. That's this command here. So if I click on this line, it'll make it horizontal or vertical, whichever it was closer to begin with. And I can create tangencies. When you're, anything that's clicked in this sketch thing, it'll try and establish it by default. So like if I turn this off and I create a line that you see, there's also this indicator, so point along, like on element. If I turn that off, now I'm creating a line and there's no relationship to that arc at all.
Hey, Greg, is this tool smart enough to let you know if a, let's say, call it a part or something that you're designing is fully dimensioned?
I don't know, but if you start changing dimensions and see odd behavior, that will tell you if something's missing. In our parlance at work, we call it under constrained or over constrained.
Right.
So I don't know if it'll tell you. That would be pretty difficult. But when you start changing dimensions and something goes awry, you'll know that it's under constrained. Or
Like,
if you try and change a dimension and it doesn't move like you expect it to, it's over constrained.
The CAD tool Fusion 360, which is a 3D free tool, that'll tell you, it actually changes the color of the lines when it's fully fully properly constrained.
Oh, that's cool.
Yeah.
I'm going to guess that that one's not free, but if it is, let me know.
No, it's free. You have to just say you're a hobbyist,
Oh,
which we
okay.
all are. Um,
Very good. So you can see that the line I just drew had no relationships. If I do that again with this point along established, when I get close to the line, or I'm sorry, when I get close to the arc, you see that glyph down under the right of the crosshairs that looks like a bar with a circle in it. That means point along. So when I click, it's going to create a point along relationship. And it's actually keeping it tangent, which I'm surprised it is because I turned tangent off. But it's because the tangent's off, that relationship's not established. I can move the end of this and make it not tangent. If I do that again with tangency turned on, it'll establish that relationship when I create it. So now when I move that end, it's going to keep it tangent. All right, so that's, I'm just introducing the different type of relationships. If I create two lines like so, the parallel relationship will keep them parallel. So now when I move one end, the other one follows. I can also make them equal length, so whichever one you pick first is going to be equal to what you pick second. So this one will now be the same length as that one. And if I change the length of this one, oop, I'm moving it instead of, all right, the program I use at work, if I pick this key point and drag it, it's going to change the length. This one doesn't behave the same way. I'll change the length by keying it in here. So you can see when I change the length, they stay in sync. And if I change the angle, then they also still stay in sync. I can do symmetry. So if I create a line, you can see that I have, this is the horizontal or vertical. And if you draw one that's straight, it'll keep it straight. So if I try and move this now, it won't change the angle because this constraint is there.
Oh, nice.
You can pick these constraints and delete them if you don't want them. So you can see that that thing gets highlighted. If I click, it's selected, and if I hit the delete key, it goes away. So now it's no longer constrained to being horizontal and vertical. I usually don't want things kept horizontal and vertical. It leads to being over constrained. So I'm going to turn this one off. I'm going to draw two more lines. And I'm going to do this symmetric constraint. So again, the prompt bar tells you what you're supposed to be doing. First thing you do is click on the symmetry axis. I'm going to make everything symmetrical around this one. And I'm going to click on two more elements. And now they're going to be symmetrical about that line. And if I change this one, you can see it keeps that symmetry. Concentric I already showed you when I was creating the two arcs, and I showed you perpendicular. Collinear is another option. So I can draw two lines. This is the collinear one here. So that one will now be in the same line as that. And if I change the endpoint of either, they'll keep it in line. It's just in line, but there's no reference to, they can still overlap. So now, that's kind of, you don't know what's going on there. But that can be helpful. And locked. Sometimes you want to keep something fixed as an unmovable reference. So if I draw a line and use the lock constraint, it is now fixed and can't move. And so now you see if I try and move this line, if I select it and drag it, it won't move because it's end connected to this one, and that one is not allowed to move. You can also, I think, I'm going to click that and delete it. You can lock just a key point. So now just that end is locked. So I can move this end, but I can't drag the line because that end is locked. Okay. All right, let's get back to our example. We've got the basis for our pattern. Now we need to dimension it. And we're going to do that by going to the tools and clicking on this variable table. And start doing some things. You can see the dimensions that we created are in here. So we can give these names so that and variables so that they are more easily understood. So we're going to call this RI for inner radius, and I can actually give a note what the RI means. I could name this pattern inner radius, but I'm going to use it in some formulas, and then the formulas become quite complicated. This one is, I'm just going to call this L for the pattern length. And I'm going to call this S for the pattern sweep angle. All right. Let's see. Give me a moment, I'm referring to my notes. Okay, so this is the pattern, but what we know is what we want for the final cone. So I'm going to establish a variable. It's not a dimension on the drawing, it's just a variable. I'm going to call this RT for the cone. Come on. It won't let me add a comment until I put in a value. That's what it is. For my bucket, I wanted a top radius of 12 inches, so I can just put in 12 here. Now let me put in a comment. Cone top radius. And I know what the bottom radius is, so I'm going to put in RB. The bottom is 9 inches. I'll call this the cone bottom radius.
How come it's showing the radiuses in degrees, though?
Because they're just variables. It doesn't know what it is, and it's probably picking whatever the last entered one was. I think I can change that, but it's really just a scalar value. I'm not going to bother. Is there an option here for unit type? Up here. So if y'all want, I can change this to distance. There we go. And I know the height of the bucket, so I'll call that H, and it's 10 inches tall. These notes are not required, but it helps me when I'm looking at the formulas later if I can't remember what RT was supposed to mean. That's where it helps. Okay, so I'm sharing just the application. I want to share my screen, so I'm going to stop sharing for a moment and start sharing whatever's on my screen. And go to the web. And I hope I saved this earlier. I just Googled how to create a pattern for an unfolded cone because my math isn't all that great, and I wasn't sure I could come up with the formula myself. So if you're in doubt, just use Google. It's a great tool. And this is showing all the math behind it, but he did skip one step that I had to dig into my memory to do. So as you can see, we have the top radius, the bottom radius, and the height is going to be, we need this length. And it's just a right triangle. The bottom of it is half the difference between the bottom and top diameters. And the long side is the height. So Pythagorean formula for that is simple enough. So I'm going to go back here and I'm going to do a variable f, which is the flare, how much it goes out just on one side. And I can type in a formula here and say that that is the top radius, which is the larger one, minus the bottom radius. And you have to put the parentheses around it to get, I don't know, is it a programming thing or a standard math thing? There's a difference between this and RT minus RB divided by 2. That would be the top divided by half the bottom. We don't want that. We want the top minus the bottom and then divide that result by 2. That's what the parentheses are for.
That's right.
So 12 minus 9 is 3. Half of that's 1.5. That's correct. So we'll call that the flare. And I already have the inner radius established, and the length is that formula we just talked about. So we need the height squared, and you do squares with this caret, so that's h squared, plus the flare squared. And I forgot to start, and then there's a function, SQR means square root.
That's right.
So there we go, the length is now correct. And it got a lot bigger. So I'm going to zoom that over. And we're going to need pi. So I'm just going to establish a variable pi. And 3.14159 is a good approximation for that. Now we need the top circumference of our bucket and the bottom circumference of our bucket. And let's see. Yeah. I'm sorry. Yeah, I was just referring to my notes to see if I wanted the circumference of the pattern or the bucket. I think it's the bucket. So I'm going to say circumference CT for circumference top. And that's going to be pi times the diameter. So we have the radius. So it's going to be 2 times the radius top times pi. Abbreviate circumference. And the circumference at the bottom, which is 2 times the bottom radius times pi. Believe me, guys, we're getting there. All right, we're going to need the ratio of these two. So what did I refer to that to before? I'm going to call, I'm just going to, so R looks like a good abbreviation for ratio, but that could be confused with radius, so I'm just going to call it K. And that's going to be the bottom. I want to use the smaller one first, so it's the bottom circumference divided by the top circumference. Right. Now the inner radius formula is the one what the website skipped. He just said, all right, now we know the inner radius is that. So I'm going to subject you guys to the math, whether you like it or not. I had to, this is not rocket science or brain surgery. I was still pleased that I was able to pull out my high school algebra and get this done. We know that the ratio of the radii have to be equal to the ratio of the circumference. So we know that the ratio between that radius and that one is the same as the ratio between that circumference and that circumference. We know 3 out of the 4. So we just established this ratio, the bottom circumference divided by the top circumference. We're going to call that K. So K is the same as the ratio between the bottom and the top. We know the bottom radius is the inner one plus that length. So we can replace RT with RB plus L. We can multiply RB plus L by K. So now we have RB equals RB times K. That's supposed to be plus. Mistake there. Plus L times K. We can move RB times K over to the left side. So now we have RB minus RB times K equals L divided by K. We can put this, if you can, I hope you can see that. RB times 1 minus K is the same as RB minus RB times K.
RB2.
Divide that one, or divide this by that. So now we have RB equals L times K divided by 1 minus K. Website didn't give me that. Cancel. I just want to close that one. All right, now we're back to, so now we need to put in the length. Oh, wait a minute. No, it's the inner radius formula that we're doing. So this inner radius, that formula is what we were just saying. Looking at my notes again. L times K divided by 1 minus K. Is that what I said? Yeah. So now we have an inner radius of 30 inches. Yep, okay, that matches what I had before. All right. So now the, sorry, again, I'm referring to my notes. Okay, the full circumference of this inner radius is going to be 2 times this radius that we just established times pi. And we're going to need that. So that's the pattern inner radius. 2 times Ri times pi. And all right, so what we know is the circumference of our cone bottom. We know that that is 2 times our cone's bottom radius, or in my case, the bucket. But we know the full circumference of this pattern inner radius is this one. We need that ratio. Looking for, okay, so I'm just going to call, again, R can be fused with radius, so I'm going to just call this J. And that is going to be our inner radius divided by the inner circumference. And this is just going to Bill's question. It's in degrees. This is really just a scalar. Change that one. That's inches. This is a scalar. Scalar means it doesn't have any units, by the way, for anyone confused by that.
Hold on a minute.
Huh?
This isn't really important, but I wanted to avoid any confusion, so got that taken care of.
Yeah. Yeah, let me see if I can. It's 513.
Well, I don't think I'm muted.
All right, so what proved that? So we know now the ratio of this arc length has to be the circumference of our cone once it's folded up. And we know the full circumference of this one. So we know what that sweep angle is. It's the ratio of this length divided by the full circumference. So now we know that the sweep angle is this ratio, J, times 360. Everyone follow that? Hope so. If not, we'll go back to it later. Don't want to get bogged down in the math. So that is now the pattern for a bucket, the size that I want for my model. But before, it doesn't have any handles on it, and it doesn't have any lines showing where the slats of the bucket are. But at this point, I'm going to save it because it's just the basis for whatever else I might want to do. So I'm just going to say save this as cone pattern. And now I can start doing some stuff with it to make it look like a bucket. Go back to home, and I'm going to save it again, save as a different file name. I'm going to call this bucket. All right, and so now I can start making it look like a bucket, and I'm going to do that by just putting some lines on here. All right, you see it's snapping to the end. I don't want it to do that. Just move away a little bit. And you can see, because I have this perpendicular thing set, if I draw it anywhere close to being perpendicular, it's going to let me know and keep that relationship. Every time it's trying to keep it tangent, and that's a problem for me. So I'm going to go up here and turn that off. And I don't want it to go to the midpoint or to the ends. I'm going to turn those off temporarily. But it still has the point along constraint, so you're still seeing that. And I think I want 12 segments. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. I need 3 more. Some of these are perpendicular and some aren't, so I'm going to establish that where it's missing. All right, now I can create an angle between each one of these. And by the way, like I told you before, you can start a new dimension reference by right-clicking. So in between each one of these, I'm using the right-click so that I don't start dimensioning from, like if I click here, and then here, and then click here to place the dimension. If I click here without doing the right-click, it's going to be relative to that first one, as you can see. That's why I'm using the right-click to establish a new starting point each time. And now, Bill was asking about over-constrained. If I try and place one here, I can't set all of these because the sweep angle has been established with this dimension, so I know the total. Let's do one thing here. Let's change the size of, that's too big. All right. Size of our text. I should be able to, there we go. Can't read this, so I changed the size of the text. If you select it, this is the text size here. I can copy that to everything else by using this command, which is copy attributes. So I start that, I click the one I want to copy from, and then everything oh, it's not working. Huh. It's supposed to be copying the size to each of these, and it's worked in the past. I don't know what's, let's try it one more time. Well, I don't know. You can also multi-select. If you click something and then hold the Shift key and click again, you're selecting multiple things. And then I can go in and change their size all at once. You should have been able to copy it. I did that before. I don't know why it's not working now. Okay. You can see these are black, and this is something important that I missed. Dimensions can be what we call driving, which means they set the value, or they can be driven, which means that they show you what the value is, but it's not controlling anything. This one is showing up, all of these are showing up as black because they're driving dimensions. They are setting that angle. If I change this value to 4 degrees, it has changed the angle between those two lines. This one is showing up as, call it dark cyan, because it's driven. It's driven because you can't set this total angle and each one of these individual ones. For instance, there's 12 of these. I can't set each one of these, this to 36, all of these to 3, and that one to 5. It would not add up to the same amount. This one is actually a driving dimension, but it's showing up the same color as that because there's a formula associated with it. To me, it shouldn't. The program I use at work, this would remain black, even though it had a formula associated with it, because it is a driving dimension. If this one was driving, it would be what we call over-constrained, what Bill was referring to earlier. So this one will just show us what the result is. We can go back to our formulas now, and you can see all of these individual angles I just set. I can set each of those to be the sweep angle divided by 12. I copied it using Control C, and now I'm pasting it using Control V. There might be a command up here to do it, but the keyboard shortcuts are faster. And now you can see they're all 4.77 degrees. These aren't showing the, again, I'm multi-selecting. These aren't showing any decimal places, so I can control that also. I can go up to here and say I want to show 2 decimal places. And now we can see they're all equal. So now I have these equally spaced slats. And I can now do something like draw a bucket handle. I'm going to show it intentionally distorted so we can go back to practicing our relationship commands. I'm going to turn back on these endpoint things because I will actually want to use those. So now I'm constrained to that endpoint. You can see that dashed line showing up is going to try and establish that this endpoint is horizontal with that one. That can get in my way, so I'm going to horizontal's already turned off. I think that's just an aid. It's not going to keep the relationship. Anyway, there. I'm going to use that collinear restraint we talked about earlier. Keep this one in line with that one in line with that. This line was already, as I drew it, made perpendicular to that one, so that's fine. I can add a dimension here. Call that HL for handle length. Don't need to create these variables, but you know, what the heck. How long should it be? I don't know. Call it 6 inches. And I can draw another one. Should be 6 away, so, or there should be 6 in between. 1, 2, 3, 4, 5, 6. I'm not sure I have that right. Draw it out on paper here. Five between. 1, 2, 3, 4, 5. So it's my second handle. And again with the collinear. And I'll make this perpendicular. And I want that handle to be the same length as the other one, so I'll use the equals and say that length is equal to that one, instead of creating a new dimension. That way, if I want to change the handle length, I don't have to change 2 dimensions. I just change this one, and the other one will change to match it. Just to illustrate, if I change that to 8, the other one changed to 8 also. I think we'll speed it up, and I can add a hole in the middle of this for where the rope bucket goes through. And that's that. That's my bucket pattern. So I think I saved it to an easy to find spot. Did I? Yeah. I don't want to use that one. Come on now. There we go. So what I did is I printed out that template, including where the bands went. I didn't include that in the example. And cut it out of a sheet of thin holly. My intention was to score it so that I could bend it inward, and then where it was scored would give room for where the material came together, like beveling the edges of your bucket slats. What happened was when I soaked it and steamed it in water, it expanded the opposite direction. So it made the scoring open up even more, which was detrimental. So not such a good idea. I could have tried to bend it against the way it wanted to go, but I thought that would break it. So I just went with it. I turned a piece of brass that had the right taper to it, and then slipped it over that while it was still hot and wet, and put a cone over, a washer over it to hold it in shape, and then just glued up the edges after it had dried. You can see these are more open than I would have liked them to be, but c'est la vie. And that's starting to paint it up, and that's the final product. This is a 1 cent euro piece for scale. That's the mop that goes with it. And I thought I had pictures of it in place, but I don't. You can get there easily enough. So there's a picture of one of the buckets in place with some other bilge cleaning devices. And I think there's another one on the bow. Yep, there's so there was, this bucket is a different height and different diameters than the other one. So that's to illustrate the point of this. If I want another bucket, I've got all of these slat dimensions in place. Now, if I want to make it 14 millimeters or 14 inches at the top instead, and 10 inches at the bottom instead, but only 9 inches deep, and my handle's too long, I'll make that 5 inches. Done. In a few seconds, I've got a pattern for a different size bucket in seconds. You guys getting bored with this? I can go on to pedals to mount. So this one's already started. We don't have to recreate everything. This is something like Gene might want to construct for a gun mount. I thought that there was the bottom of the cone was solid instead of the legs going all the way to the floor, so this is incorrect. I'm just going to get rid of this thing and show you a new command. Underneath, so this is the split command. There's option under there, it's extend to next. These really don't seem to have anything to do with one another. I'm not sure why they're under the same drop down, but you can extend this to the next element to quickly modify the length. And then I can use this command, which is trim, to get rid of the segments in between. And we can go into more details if you're interested. Parts of this are not accurate for Gene's example, but you could do what Gene needed. I just got off on the wrong start. But again, if you have gun mounts that are built the same, but they're slightly different diameters, it's the same thing. I use the same formulas in here, but obviously this gun mount is a lot bigger than a bucket. I've got where is it? These didn't get renamed. Where's top radius? Oh, there it is, top radius. I use 12 inches and 36 and a height of 42, just kind of guessing at numbers. But, say I was wrong, it needed to be 40. Yeah, everything adjusts to fit. Maybe this is supposed to be 16. I guess you can see the advantage of that. Now, I was just creating a template for wood. Gene was creating something he wanted to do photo etching with. So you can, I'm not sure what part's supposed to be filled in, which one isn't. Let's just, oh, that's another important element too. I'm going to turn on this horizontal thing so I can create a square box. Layers is something I forgot to talk about. You can put these different elements on different layers and either show them or hide them, and that becomes important when you want to start using the fill command. And the fill command is something that you would use to create your photo etching stuff. One other thing I hadn't mentioned is all of these handles I was telling you about that show the relationship. You can turn them off so they're invisible, but they're still active. So that is this one. It just toggles the display. So if I click that one, all of those handles go away. It cleans up the image somewhat. For this example, I wanted the legs to turn into an arc at a certain distance away from the center. So I had to create this line that isn't really part of the template. It's just there to help me draw. We refer to that as a construction line. So I created a new layer. You can create a layer with this one. Let's show. This is new. If I click this one, I can create a new layer and name it whatever I want. Fill. So I'll create a layer for the fill elements. And you can hide and show the elements using this one. So right now, construction is shown, but I want to hide it. So if I click hide, you can see all those gray lines went away. I can create another one for dimensions. And if I don't want to see the dimensions, I can select them. Again, I'm holding down the shift key to select multiple things at one time. I can click on this one, which is move, and I can pick which element or layer I want it to be on. So when you create a new layer, it's visible, but you can hide it. And why didn't that work? I think moving it didn't work somehow. Oh. All right. Oh, that's why. I said to hide it, but right now it is the active layer. So whatever these layers is selected, when you place a new line, it's going to go on whatever is the current layer. You can't hide the current layer. So what I need to do is double click on a different layer to make it active. Now I can hide this one. Now that my dimensions go away. All right. So Gene, the stuff that I want to be left, is that supposed to be black, or is it supposed to be, it's supposed to be black, right?
All right, what you have there would be solid. If you, what are you trying to?
I want to fill in. I'm going to use the fill command if I can find it. Actually, I haven't used this yet. I don't even know where it is.
Okay, in the process that I use using a positive fill, all of the areas outside of the pattern would be black. What's black is
okay,
etched away.
Right. So he's going to etch a lot more at one time than one piece, but we don't want to use too much material. So I'm going to grab these corners and make them just fit. And I'm going to use this command, which is fill. And I haven't used this before. It's going to be a hatch pattern the way it's shown. I'm going to select this, and somewhere in here, I'm sure it's going to give me an option to be solid. Oh. Don't tell me there's no solid option. Well, let's just see what happens. That's the color. Oh, solid color. There we go. Just works differently than what I'm familiar with. I'm going to make that black and click in this area. It says it couldn't be completed. Because why? Are there gaps in here? That worked. All right, so there's no gaps. These are connected. This construction line, I don't want to be there. I don't know if that's interfering with it. So I'm gonna oh, that's a relationship handle. It's not a line. It's off again.
Well, if you made your pattern black, can you just invert the image?
Oh, that worked. Let me try it again. I think maybe I accidentally clicked outside that box. So if I click out here, outside the box, it's going to try and fill in the entire semi-infinite sheet. And I can't, yeah, I clicked out here. That's what happened. Needed to be inside the box. I thought I was. That's not the solid color again. I need to do this. All right. So anyway, now you have your etching pattern ready to go. So there are a lot more commands in here. I haven't learned them all. We won't need them all, but there's a lot of interesting things. You can do a bolt hole circle. I don't know. It helps you create. You could do all this manually. This is probably like a shortcut thing. Helps you do it, establish it more quickly. I haven't even tried it yet. There's tons of stuff in here. That's all I had for today. There's lots of other things. Let me show one other thing. Is I said I'd used it for other things like templates. So I can create a new image, and you can use this one, import an image. And I'm going to pull in this is the model I'm working on right now. And one of the things I did was it would make, it would be even a better illustration if the model had more rocker than mine does. This is not perfectly straight. You can imagine it being even more curved. If you're going to bend that, you might want to know the overall length of it. You can measure it off the drawing yourself, but it's a lot easier if you use this tool, the curve tool. When you bend things, they bend about the middle of it. So I'm going to just click along here. To create this curve. And I'll have to pick a few more points when I get around the bend here. And then I double click when I want to finish it. No, I don't, I right click, sorry. And now if I select that curve and right click, I can go to the properties and it'll tell me the length. So then I can cut one that's 11.02 inches long and bend it, it'll be the correct length. So again, tons of uses. I'll just open it up for questions if there are any.
Hey, Greg?
Yep.
So I guess what we're saying here is that you could upload a plan and trace it.
Yep. I've done tons
Yeah.
of tracings on this. One thing I did, I was trying to figure out if the body plan for this was molded surface, the inside of the planking, or the outer surface of the planking. So what I did was I sketched a line from here. You can see that's a little bit. I did have to do this. The drawing wasn't scanned exactly, but you can rotate it as much as you need to.
Mm-hmm.
So I rotated it by 0.1 or 2.2 degrees, and then these lined up. I'm not going to bother doing that right now. But then I just started tracing the inside. I can do this more accurately. I'm doing a quick slap hazard example right now. And we'll just leave it there. And then selected everything and used the move command to go from that point, and then zoomed in to that same point and place it there. And then I can see, oh, that's to the inside of the planking.
Gotcha.
So, you know, again, that's just another example.
It looks like there's a lot of the same stuff that you have there in AutoCAD, but AutoCAD is a whole lot more esoteric, at least the version that I used to use.
Mm-hmm. Well,
And it's not free.
yeah.
Yeah, it's $3,000 not free.
Yeah, the my company has its own 2D drafting software that is also not free, which is what held me back from doing this presentation using my company's software. But when they both programs use the same internal relationship engine. The thing that kept all the lines connected and parallel and collinear is from a third company, and we're both using that technology. So my learning curve was extremely fast. All of this stuff is almost identical to our own software, but it's free.
How does this compare to something like TurboCAD? More or less the same, or?
I haven't used it, so I can't say. I did a QuickCAD is free, QCAD, and that is a spin-off of another one. His name is escaping me right now. And they seem to be the most popular. If you do a Google search for free 2D drafting software, those come up on top. But they're nowhere as good as this, and they don't have the relationships for one, which I use extensively.
If you're interested in a 3D CAD tool, take a look at Fusion 360.
Okay.
That is free to the hobbyist, and it's very similar to the sort of the thinking of the 2D tool that you're using here.
Mm-hmm.
But what you can then do is obviously revolve things into to 3D, and then you can render things. It has a rendering tool which would make it look with shadowing exactly like not exactly, but how it would look in real life.
That's probably better than SketchUp, which I've played around with just a little bit.
Google SketchUp. To me, it's much more. It's much better than SketchUp. Although SketchUp is improving, I think they just came out with a new release. So they're constantly improving it.
Okay.
This program lets you do a third view projection though. Like if you were, for example, wanted to just to pick something, you wanted to do the rails. I'm not coming up with the right at the head of a sailing ship, a period sailing ship. You know, you make templates, but what you could do is you need a true length to know how big the template is. If you wanted to do that off a drawing, you could, you know, you project it, and you could make a third view projection so you get a true shape. You know, and I think you can do that with this program, looks like.
Another thing I did, once I established the fact that these lines were to the, what did I say? They were to the, I thought
Inside.
inside is what it showed. I actually thought I determined that they were to the outside. So maybe what I just did was inaccurate, but let's just say it was to the outside, and you need the inside. What I had done, and then later, much to my chagrin, because gosh darn it, I have a naval architecture degree, should have known better. I just used this curve tool. Now, I stay away from using this curve tool to actually fare through points, because it's easy. It's not like a spline, and you can easily make it serpentine, which would be no good. But if you already have the line established, and you can get it to look smooth and right along there, that's accurate. And then you can use offset command, if I can find it. There we go. You can select that curve, and then, oh, actually, maybe our program will let you offset a spline. Not sure this one does. Yeah, okay. I had to enter a distance. So if I want it to be 0.02 inches, it just moved it. And now I have my inner dimension. Well, that's true if you're right at midship and it's not pointing in. It's also true if you're, but the projection is not that simple. So when you get up to here, let me, if you're looking down on top of it, what I just did was move the body plan, which is here, inward 0.02 inches, but the plank thickness is actually this direction. So it's actually not accurate. It'll be very accurate at certain points of the hull and very inaccurate at others. So I made all of my templates by doing that, and now I think the ones at the bow and stern are probably not very accurate. I'm not going to lose any sleep over it. I'll just fare it by hand, and if it's a wee bit off, it's going to be a wee bit off. But just a word of warning.
And is that what 3D lets you? You're able to actually set it up in 3 dimensions and fare and take all that stuff into account?
Yeah, you can take a 3D surface and shrink it inward, and it'll be very exact. I'm not sure which free programs will let you do that, because that's a pretty intense operation.
Yeah, there's educator discounts on a lot of these that, like the 3D on this, instead of being 3,000, is under $100 with the educator discount.
RhinoCAD is a very powerful 3D tool as well. I'm not sure what discounted or free versions they might have.
One thing I was thinking, Greg, you know, I mean, you could be totally anal about it though, but instead of just using the offset command, what you could do, like with your bucket, is you could probably at several points along that curve, just put equidistant points along that curve, and then to each of them put a plank thickness projection line, from that
Yep.
curve, construction line, and then connect up the points off the construction line.
Yeah, it was too late for me to go back and do it, but we know that the plank is in this direction. So we know you can figure out where it would project on there and get that distance and then set those points and put a curve through there. I was worried about it for a little while, and then I realized that, this is a lap strike hull. The planks at scale, I think, are 0.04 inches or something. I can do them. I can't remember what it came up to. Yeah, 0.035 inches. No one's going to see it. I don't care.
This is true. The only person who would know is you, and you're not going to try to build it in full scale. So
no. I worried about it. What mostly bugged me was that with my degree, that should have been immediately obvious. But now I haven't really. Most of my time as a naval architect was done in machinery system design, not in hull fairing, and that was 20 plus years ago. So I try not to kick myself too hard.
I'll give you a pass, Greg.
Pardon?
I'll give you a
Question.
pass.
I'm sorry.
Go ahead, Don.
The images you had scanned in,
Uh-huh.
what size were they when you scanned them? Or did you import them electronically or?
Yeah, so that's the other thing. This is after I did the work. I scanned it in, and it's not going to be the right length. So what I did was drew a line from here to here. After rotating it a wee bit to get this line that I just drew.
Mm-hmm.
If it doesn't have a horizontal constraint, it should, because I want it to be horizontal.
Right.
All right, it's already there. I rotated it a little bit to make the drawing line up with it. I'm not going to do that now.
Right.
But you can see it's 13.579 inches. That's my scale model length. I had done this before. It depends if you want to draw at scale or you want to draw full size. So before I was drawing at scale. If I were to redo it, I'd draw it full size. So I would just take that, whatever it came in at, it could be anything. When you scan it, you don't know what it's going to be. Do the math to get it to be full size. So I know that this is 27 times 12 plus 3. It should be 327 inches long, but it's actually 13.579. So I'm going to divide that by 13.579. I need it to be that much times bigger. Now again, this is 20. I'm doing it 1:24, but when I scanned it, it was probably something off of that.
Right.
Click the image and use the scale command, which is in this drop down. So the one that they show is mirror, but an option under that is scale.
Okay, cool.
To find these things, you're going to have to play around. Paste in your scale to that box, hit enter, and it's asking me to click on something. I don't know if I'm in the select yet. All right, so it's going to ask me to select the center scale point. I'll click somewhere in the middle of the drawing, and then it just created it. Scale everything by 24, I hope.
So I could technically scan in a image from one of the collection of books I have. It's probably going to be really muddy because the books are small, but I could probably blow that up and clean it up and get a workable set of frame plans off of it if I wanted to using this.
Yep. So
Instead of the drawing board.
I don't know what happened to the line that I'd drawn before. It seems to be gone. But this new line is 327 inches.
Okay.
So now I have a drawing that is full scale, and I don't have to do the math. You know, if I want to draw a 12 by 12 box on this for whatever reason, full scale, I don't need to, you know, do the math to do it at scale. Oh, God, and that reminds me, we do need to print these things to scale at some point. I totally skipped that part. This is my drawing sheet. This 2D model tab is the full size one. This is what I actually want to print. So to get it in here, you go to tables, select 2D model, and it goes back to your model. Let's go back to the bucket example instead. Close this one. I'm sorry, I'm trying to think and talk at the same time. Did I answer your question, Don?
Yeah, basically. I mean, I've operated AutoCAD.
Yeah. So yeah, certainly you can import drawings, scale them as you see fit, and create patterns or templates or whatever.
What you went over, Greg, frankly, is enough of a start for, you know, to get most of what I would use this for, frankly. This to me is the commands look a lot like, not exactly the same, but they look a lot like what I'm used to from AutoCAD, although I used it very sparingly. I do have a copy of TurboCAD, but those commands are a lot different. This seems a whole lot better. The user interface seems a whole lot better. And the price is right.
Yeah, the price is definitely right. I don't know what happened. I don't know where I saved.
Well, if I need a bucket, I'm going to Ace.
What's
All
the
right.
name of this tool again, and who puts it out, Greg?
Solid Edge 2D, and it's Siemens.
Okay.
Yeah, this is certainly, there are other programs. You mentioned Fusion 3D. There are other ones that will work. I picked this one because it is very powerful, and it's very similar to what I use at work, so my learning curve was really short. If you're learning something from new, you can choose which one you want. You'll have a learning curve regardless. You won't be at a easy starting point like I was. So pick what looks good to you and run with it. Gene's already familiar with Photoshop. Maybe he wants to stick with that. What was I trying to do? Yes, printing. So I'm not going to bother turning off all the dimensions with the layers like I did before. I'm just going to go to the sheet, and I'm going to go to tables, 2D model, and it's going to, you can see there's already got a window cursor thing there. You just click and then select whatever you want to be shown in your printing view, and you can see it's full size, but that's not what we want to print it at. So you go to now I have to remember if this is the right place or not. Settings, sheet setup, and put in your scale. Unfortunately, 1 to 24 isn't one of the drop-down options, but you can put one in there. So 1 divided by 24 is this. I can paste that in there. And that didn't work. Oh, all right, never mind. That's not how it's done. You select what you pull in, and you put the scale value in here. That didn't work. Well, let me paste it. So I have to hand type it. What was it? 04 and a bunch of 6s?
0416.
Yeah. All right, so now that's to 124 scale. I don't know what size sheet this is. It must be pretty big. If
This
I,
looks like a B
if I go here to settings, sheet setup, that's this is a 36 by 22. I can just pick a size sheet, 8.5 by 11.
Oh, nice.
This is the wrong. I am still getting used to these. Somewhere in here. You can change this background. I can't remember how. Ah, there we go. A sheet. Do the same thing. It should have started there. And there. Now, and you don't have to have this fancy background. You can do it on a blank sheet as well. I can't remember how you turn off the background, but you can create a new sheet that doesn't have this drawing format and just have a blank piece of paper. But then when you print this, it'll be the right size. And you can change the line widths, perhaps on your 2D sheet, because these look a little bit thick now. But that is how you go from full size to whatever scale you want to print it at, by pulling it into another sheet and setting the scale there. If it's something where you have, I saw this illustrated. Let me just draw a couple boxes. I can, oop, that was a mistake. All of these I have to shrink down. Each time you go back to the 2D model, you can pull in a different thing. But maybe these were part of a 3D view that really should have, they were aligned in your original one, but now they're not. You can align these. I've seen it done. I don't remember where it is, but there's an alignment tool, or maybe you just drag it. Yeah, so I tell, my wife frequently asks me how to do something on a computer, and I tell her, when in doubt, right click. That's true of everything. I wasn't sure how to do it, so I was in doubt. I used right click, and there it is, create alignment. So now I can say that this is, the default is view centers, but you can use key points instead. So now I can say that is going to be aligned with that, and it'll line it up for you.
Oh, very nice.
So then you can pull in different views from your 2D model, and if you need them aligned, you can do it that way. Any other questions? All right, cool. Well, that's an introduction to Solid Edge. Be creative. Like I said, I've used this for making templates, making measurements, creating jigs to do different things. The world's your oyster. Or I think that's the phrase. Yep, no, I'm gonna, since there don't seem to be many more questions, I'll stop sharing. Stop the recording.
That was good, Greg.
The cannon, I put it in, I parametrically designed all the things so you could scale to any pound cannon you want, like he had shown. And they also had an aspect where you could then take that and send it to a place that would do a 3D printing for you, you know, hard resin or whatever. So I did that. And I remember talking to Chuck Pissarro, who owns Siren. And I said, well, Chuck, you know, I could supply your cannons. He says, oh, yeah, how much do you can get them for? I said, well, per cannon it'd be about $20. And he just laughed at me. So, you know, it's for what you want to do. If you're manufacturing, if you're making a lot of them, maybe you can get the prices down. Or if it's just a niche, something that you can't get or easily make, it's a nice option to do, because it just sort of, you can lend it right, put it right into a 3D model and then 3D print it. So it's just fascinating, this stuff. It's really evolving quickly.
Cool.
Well, thank you, Greg.
You're welcome.
Good job.
Anything else we want to chat about, or are we going to wrap this up?
Yeah, great.
So Heinz, smoke?
Going to the beach.
In the pre-meeting, Heinz asked me if we were going to go to smoke afterwards. I said I'd be happy to, but it's kind of a long drive for him.
Is he paying?
Yeah.
Unmute yourself, Heinz.
Heinz, you have you're muted. You have to, on the lower left, there's a microphone shaped thing. Click on that. I might be able to do it for you. I'm not sure if it'll allow me to, or I can only ask him to. Where is Heinz? Like ask to unmute. I clicked on ask to unmute. It should prompt him, but
Yeah. There you go.
there you go.
Now we can hear you.
Nice seeing you all.
Oh, it's great seeing you.
All
Well, all right. Good night, everybody.
right. All right. Cheers. It looks like we're wrapping this up.
Thanks, Greg.
Bye-bye.
Until next time. Try and make it to your next meeting, Bill and Tom.
Bye-bye.
Good seeing y'all.
Bye all.
Have a good one.